Okay, so looking at page 109, looking at this function, like she just said, this is going to be a horizontal stretch. And the reason it's horizontal is because it's with the x, so it's a horizontal stretch of 2, and then it's going to go down 4. Okay, what about this one now? So what did you put for this one, Mitchell? Good. Reflect in the y-axis, vertical shrink of 1/8. Good. All right, so now let's flip over to the back on number 7 with transformation. So this function, we're starting off with this function that we're given. We're supposed to graph g of x, which is going to be negative f of x minus 3. So look at what they did. They replaced x with x minus 3. Looking back at the front of our notes on page 108, what happens when we replace x with x minus 3? What kind of a shift is that going to be, guys? It's going to take us to the right 3 units. So right here, this takes us to the right 3. So I'm going to move to the right 3. That vertex scoots down to here. What does the negative out in front do for us? What's it do, guys? The negative out in front. Right. Takes it over the x-axis. So now this function is going to look like this. Okay. On these, we're not actually going to graph them. I just want us to come up with the rule for it. So here's our original function. It's telling us to find the function that would be f of negative x. So that means wherever we have an x, we have to replace it with a negative x. So our g of x function, we have to replace the x with negative x. Then we have to cube it. We still have the plus 8. So for just doing the first step, we're going to have negative x to the third plus 8. But what does this say we're going to do with it now? Down 9, so I have to subtract 9. So then my final answer for g of x is going to be negative x to the third minus 1. And the shift that's going to be, it's going to be a reflection over the y-axis and a shift down 9. This one is saying g of x is going to be 5 times f of x. So all we have to do to find that is just multiply the whole function through by 5. What kind of transformation is that when we multiply the entire function by 5? Vertical stretch. So this is going to be a vertical stretch of 5. Okay, so down here we're supposed to write a rule for g that represents the indicated transformation of the graph of f. So here's our first function. It says we have to translate 1 unit left. So looking back, if we want to translate 1 unit left, what do we replace x with? X plus 1. So to do this, wherever we have an x, we have to replace it. So to find our new g function, x is going to have to get replaced with x plus 1. And I have to cube this out and then square this out, multiply it by 6. That's just to do this part. When I cube this out, this is going to end up being x to the third plus 3x squared plus 3x plus 1. I'm kind of using Pascal's triangle, and I just kind of have it memorized. It goes 1, then 1, 1, then 1, 2, 1, then 1, 3, 3, 1. So this is what I'm doing. It's going to be 1a to the third plus 3a squared b, b is 1, See how A is x and B is 1? So that's how I got that quickly. Can anybody do x plus 1 squared that quickly? Do you know what that would be? Go ahead, Amisha. Good. And then I have the plus 5. So then, simplifying this part only, I would have negative 6x squared minus 12x minus 6. And then I'm going to combine all my like terms. So this function is going to be x to the third. I have 3x squared minus 6x squared. That's going to be minus 3x squared. Then I have 3x minus 12x. That's going to be minus 9x. And then I have, this part I already rewrote. And then I have 1 minus 6. That's negative 5 plus 5. That cancels, doesn't it? So after simplifying all of that, that's what I ended up with, just from the translation 1 unit left. Now I have to have a reflection in the x-axis. To have a reflection in the x-axis, look at what we have to do in the x-axis. Is it the whole thing that gets multiplied by a negative, or do we replace x with negative x? The whole thing. So to do the reflection in the x-axis, I'm now going to have negative x to the third plus 3x squared plus 9x. That's that part. Finally, we have to have a vertical stretch by a factor of 2. What do we do, guys? Replace just the x or multiply the whole thing? The whole thing gets multiplied by 2. And so this would be our final answer for doing all of that. Now we're going to do one more. We have a horizontal shrink by a factor of 1/3. What about on this one, guys? Do we multiply the whole thing by 1/3? Do we replace the x? What do we do? Good. Replace the x with 3x. So I have a 3. I have to replace the x with 3x. Replace that x with 3x. Everywhere we have an x. That's how we have a horizontal shrink by a factor of 1/3. So now I have to multiply this out. 3 to the 4th. 3 times 3 times 3 times 3. What is it? 81 times 3 is 243. X to the 4th. 3 to the 3rd. What is it? 27. 3 squared times 3 is again 27 plus 12. So we've done the horizontal shrink. Now we have to do a translation 8 units down. Do I replace the x or do I just put minus 8? It's just minus 8 from the whole thing, combine like terms. So nothing changes except for that constant. So far we've done this now. Last thing, a reflection in the y-axis. What do we do for a reflection in the y-axis, Caroline? Do I multiply the whole thing by negative, or do I replace the x with negative x? Right? We replace the x with negative x. So everywhere we see an x, to do a reflection in the y-axis, we replace it with negative x. So if I have a negative x to the 4th, is that going to be positive or negative? Positive. So 243 x to the 4th. Negative x to the 3rd is negative, right? Negative x squared is positive. And positive 4 doesn't change. Alright? So you can see how it's kind of difficult putting it with all of that stuff. Alright, very good with that. Guys, today's block day, so we have another lesson too, but this one is much easier than that one was. So open in your book to page 120, 121. Alright, first thing we're trying to do is we're trying to find a function for a cubic whose graph passes through the given points. We did this already with parabolas, and here's what we did. This is a cubic, though, instead of a parabola. This has to be y equals, here's one of my intercepts. What would that intercept have been as a factor? X plus 1, good. Now, there could be any coefficient in front of here, too. I have to put an A. So that's X plus 1. Now, what about this factor? What would this one have been? X minus 1, and what would it also have to have been, though? Squared because of the balance. So I know that this function would work, okay? But here's the thing. I have to know what A is. So I have to see if there's any other point on here that we know. Well, just so happens they gave us this point. So what am I going to do with that point? Plug it in for X and Y, right? So I'm going to plug in 3 for Y, A we don't know, 2 for X. So figuring this out, 2 plus 1 is 3, 2 minus 1 is 1, 1 squared is 1, times the 3. So I get 3 equals A times 3. So what's A going to be then? Just 1. So here's my equation. Y equals 3 times X plus 1 times X minus 1 squared. And we could have checked that on our calculator too. We're not going to check that one, but we will check the next one. Let's go down to number 4 now. Yeah. Oh, I'm sorry. Thank you. Yes. I said 1 and wrote 3. So yeah, that should be a 1. Okay, now let's go down and let's look at number 4. Okay, same kind of thing. We're going to say y equals A times, what's this factor going to be right here? I'll tell you what's this factor. All right. Okay, what about the next factor? Maya, what's that going to be? All right. Drew, what's the next factor going to be? All right. And then Dominic, do you remember what I do to figure out what A is? Is there another point on here, Dominic, that's not an x-intercept that we could use? All right, 0, 3. So this is x and this is y. So I'm going to plug in 3 for y. A we don't know. For x, we're going to be plugging in 0. So this is going to be 2 times negative 1 is negative 2 times negative 3 is going to be 6. So I'm going to get 3 equals 6a. So what's a going to be? 1/2. So here's my equation then. Y equals 1/2 times x plus 2 times x minus 1 times x minus 3. Now, I might want to check that just to make sure it's right. So I could go under y equals, put in 0.5 times x plus 2 times x minus 1 times x minus 3. If we did that correctly, then when I look at my table of values, I should see those points. So I should see the point negative 2, 0, the point 1, 0, and the point 3, 0. I should also see that other point is 0, 3, and I do. So that's how I know that my answer is correct. All right, guys, on the next one, we're going to come up with formulas for these. You have to remember what we talked about with this. When we look at the first differences, if the first differences are all the same, then we know that the function's linear. If the second differences are the same, it's x squared, quadratic. Third differences, it's x to the third. So we're going to find the differences. Negative 6.5 minus negative 14. That's going to give us 7.5. So this difference right here is 7.5. 0 minus negative 6.5. Well, that's going to be 6.5. 5.5 minus 0 is 5.5. 10 minus 5.5 is 4.5. 13.5 minus 10 is 3.5. So are all those numbers the same? No. So therefore I have to do differences again. So I know it's not linear. If those were all the same, it would have been linear, but it's not. 6.5 minus 7.5, that's negative 1. This is negative 1. This is negative 1. This is negative 1. Are all those the same? So what do we know about this function then? It must be what? Quadratic. If I had to go one more time to get them all to be the same, it would have been cubic. So here's what I'm going to do. I just go to Stat, Edit. I have to use L1 and L2. Excuse me. I need to clear those out. So putting in our x's, then put in our y's, if we want to see our points, we can see them by turning on our stat plots. To turn on our stat plots, we go to y equals, and we just make sure that the top right there, plot 1, is turned on by pushing enter. It needs to be highlighted. I'm going to clear out this old equation, and I'm going to hit graph. There are some of my points. I may not be able to see all of them because the window's fine for the x's, but the y's go from like negative 14 up to 13.5. So I just going to make my window like that. There are my points. So this should be a quadratic that goes through it. It kind of almost looks linear, but it's not quite. So we're going to go to Stat, Calculate, Quadratic Regression, enter again. This right here, what does this right here mean? 8.1 times 10 to the negative 13. What's that mean, guys? That's 0. This is scientific notation. It's 8.1 e negative 13. It's 8.1 times 10 to the negative 13. That's going to be 0.12 zeros, 81. So that's really 0, guys. When you see something like that, that's going to be 0. So then here's my equation. Y equals 0.5, or is it negative? Negative 0.5 x squared plus 6x. See, the calculator is telling me to use this equation. This is my a value. This is my b value. The c is 0. The r squared is 1. So now I could put that into my equation here. And we're going to see if it passes through those. And it does. Okay? All right. One more. Let's come over to this side right here. So this one says the table shows the population of Y of bacteria after X hours. Find a polynomial model for the data for the first 4.5 hours. Use the model to estimate the population level of the bacteria in thousands after 1 day. Well, guys, one thing we have to look for is that these X's have to be evenly spaced. Are they evenly spaced? This is 0.5. This is not 0.5, though. So I need to find at least 3 points that are evenly spaced. What could I use that would be evenly spaced? You have to have at least 3 to create a polynomial. Yep. Yeah. These are the only points I'm going to be able to use because they are evenly spaced. So to figure out whether it's quadratic, linear, etc., I'm going to work with those. So the first one, this difference is 15.5. Find that difference. That's 75. Well, actually, that's not going to work very well, is it? Because we can't tell for sure what the next difference is. We don't have anything to compare it to. So, let's see here. What can we do instead? Well, what we can do is we can put this data in, and then we can just check our R-squared and see which one it's best for, too. See what we could do that with that. So go to Stat. So when this happens, we're just going to want to put in our x's. Because we don't have enough data to check the differences on our own. Okay, so I have these all typed in. I'm going to go to my window. I want to look at them because I might be able to tell even just by looking. I'm going to make it go to like 7, fine. My y's are going from like 0 to 100. Okay, so looking at that data, here's my old line. Get rid of that. Quadratic, I guess it was. Okay, so what does that appear it might be? Does it look linear? No. Does it look quadratic? Maybe. So let's calculate it. Stat, calculate. So we're going to see if it's quadratic. Enter, enter. 0.998. Is that pretty quadratic? The closer it is to 1, the better. That's a pretty good thing there. So I'm going to jot that down, that if we go with quadratic, it's 0.998. So now I'm going to check, it could be a cubic though, so I'm going to check the cubic. So calculate a cubic. Okay. That R-squared is 1, but look at the B and C. What are the B and C there? 0. Well, because that R-squared is better, we're going to have to go with the cubic. Let's just, to see, I'm going to check a quartic too. Let's see. Oh man, that's 1 as well. But if you look at this quartic, look at this. What did I say this really is? 0 for x to the 4th. So what does it end up really just being then? A cubic, right? So our cubic was actually the best estimate. So I'm going to go back and get that cubic again. Okay, so this is the best one then. We're going to go with the cubic, and it's going to be y equals x to the 3rd plus 5. And now I'm going to put that in and see if it goes through those points pretty well. And it sure does. Goes through just perfectly. Okay? So you see what I mean? If we had enough data that was spread out evenly, I could have checked the first differences, second differences, and the third differences would have all been the same. But because these were not evenly spaced, I had to just kind of guess and check with that. Any questions? All right, guys. Good job.